So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
Work and power. Work is defined as distance multiplied by force. Although other units like inch-pound or inch-ounce may be used, foot-pound is the most commonly used unit when stating work. In the example below, both men moved a 600-pound pallet 15 feet. The work done by each man was 9,000 foot-pounds. Work equals 15 feet times 600 pounds, so work equals 9,000 foot-pounds. Power is work done per unit of time. It is most commonly stated in foot-pound per minute. Power equals work over time. Since work equals force times distance, the power formula is often written as power equals force times distance divided by time. Power calculations. Although each man below did the same amount of work, the power calculation for the man on the lift motor will be higher because he accomplished his work in a less amount of time. The power calculation for the man using the pallet jack is power equals 600 pounds times 15 feet divided by 6 seconds. So power equals 1,500 foot-pounds per second. Multiply power stated in foot-pounds per second by 60 to convert to foot-pounds per minute. So here power equals 90,000 foot-pounds per minute. The power calculation for the man using the lift motor is power equals 600 pounds times 15 feet divided by 2.5 seconds. So the power equals 3,600 foot-pounds per second. We multiply power stated in foot-pounds per second by 60 to convert to foot-pounds per minute. So power equals 216,000 foot-pounds per minute. Given the information below, how would we calculate work and power? Work equals force times distance. Here, force equals 4,895 pounds, and the distance equals 35 inches. Since the distance is stated in inches, you must divide by 12 to state work in foot-pounds. So here, work equals 14,277 foot-pounds. Power equals force times distance divided by time. So here the power equals 14,277 foot-pounds divided by 10 seconds. And since the time is stated in seconds, you must multiply by 60 to state power in foot-pounds per minute. So here the power equals 85,662 foot-pounds per minute. Calculating power in rotational mechanisms. In the earlier example and practice problem, distance was measured in a straight line, or what is termed as linear measurement. But in many mechanisms, such as the example below, distance cannot be measured in a straight line. The formula for calculating power in rotational mechanisms is shown here. As you may have noticed by working on problems from the previous page, the final answer for power can be a large number. For this reason, horsepower, which is just another way of stating power, is usually used to state the power of a mechanism. Although horsepower is not covered here, being able to calculate power stated in foot-pounds per minute is essential for calculating horsepower later. In the example below, the pulley diameter is stated in inches. In step 1, inches are converted to feet so that all of the units are in foot-pound per minute. Step 1. Calculate torque in foot-pounds. Torque equals radius times force. Radius equals 3 times the diameter divided by 2. Torque equals 3 inches times 30 pounds. So torque equals 90 inch-pounds. To convert 90 inch-pounds to foot-pounds, divide 90 by 12. So torque equals 7.5 foot-pounds. Step 2. Substitute the values for T and RPM into the power formula. Power equals 2 pi times T times RPM in foot-pounds per minute. So power equals 2 times pi times 7.5 times 1750 in foot-pounds per minute. So power equals 82,467 foot-pounds per minute. Congratulations! You have completed this learning activity, Work and Power. If you like this video, please subscribe to our channel and we'll let you know if we have something new for you to learn.